Okay, so welcome to your first flip video for our sixth grade class. We'll see how it goes. Excuse me if I say a lot. And yeah, make sure that while you watch the video that you take notes, you take really good notes. Please be reminded that it is a video so you can rewind and you can play it as many times as you like. By all means, play it as much as you need it. Like, please. It's here to help you. Okay, so we are starting a review of the third 9 weeks because I feel like it's critical. We are almost done with the 9 weeks, and it's almost time for the benchmark test, and I want everyone to move up in their colors, okay? So the first thing that we're going to talk about is this here expression. I have 2x plus 3. All right, so we have 2x plus 3. If we can go through this and name the different parts. So we have a 2x plus 3. Our 3 is the easiest because it's by itself. This is called a constant. Now we have 2x. We have a number and we have this letter thing. This letter thing is called a variable. It could be any letter in the alphabet. It could be A, B, C. Remember, my favorite variable is K. So this is a variable. And this right here, anything that is attached to a variable, it is called a coefficient. Make sure you write that down, please. Thank you. So now that we have the different parts, we have 2x plus this 3. These are our terms. So anything outside of the operation, which is addition, are your terms of your expression. All right, so the next thing that we did after we named the parts of an expression, we began to combine like terms. Now, if you ever see y plus y plus y, okay, if you can kind of backtrack, what is repeated addition? Repeated addition is nothing but the same thing as multiplication. So if I have y plus, oh, this glare is kind of bad. If I have y plus y, that's the same as saying 3y. All I did here, number 1, is I combined my like terms. And number 2, I ended up giving an equivalent equation, or expression, excuse me. I ended up giving an equivalent expression. So if I were to keep going, if I have 3x plus 2y minus x plus 5. Remember, if I'm combining like terms, can I combine this 3x and this 2y? No, I cannot, because they do not have the same variable. They cannot be combined. Don't try it, okay? But this 3x and this x over here, I can. Now, the sign that's in front of this x over here is a minus sign. So with this 3x and this y, what am I going to do? What operation am I going to perform? I'm going to perform subtraction. So in combining these like terms, I'm going to do 3x minus x is going to give me 2x. Do I have anything that I can combine this 2y with? Do I have any other y's in this expression? No, I don't. So I can't combine it with anything. So I'm going to bring my 2y down. And then last but not least, I have a constant over here. Do I have any other constants that I can combine this with? No. So I bring that down as well. So my equivalent expression here is going to be 2x plus 2y plus 5. This is a distributive property. If you remember, I have this number on the outside of my parentheses, and then I have my 8 plus 2 on the inside of my parentheses. To even begin solving this, we have to recall, please excuse my dear Aunt Sasha, or PEMDAS, or please excuse my dear Aunt Sally, whichever you prefer, to solve this problem. Now, if I do PEMDAS, I always write it down the side of my paper to remind myself of the steps. So the first one is parentheses. I can solve this 2 different ways, but the first way we're going to solve it with PEMDAS. So I solve this in parentheses first. I have 8 plus 2, and that's going to give me 10. I keep that in parentheses, and I rewrite the rest of my problem. Now, this 2 on the outside of my parentheses tells me that I'm going to multiply. So 2 times 10 is going to give me 20. Now, another way that I could solve this is using the distributive property. Again, I'm going to rewrite my problem just to show. If I'm doing a distributive property, all I'm doing is I'm taking this 2 and I'm multiplying by this 8, and then I'm taking this 2 and then I'm multiplying by this other 2. So I'm going to do 8 times 2 is going to give me 16, and then 2 times this other 2 is going to give me 4. Again, I rewrite the rest of my problem. 16 plus 4 is going to give me 20. Either way, I get the exact same answer. Now, if I were to have, just a quick reminder, if I were to have 4x, okay, This 4 beside my x tells me that I am multiplying. Okay, I'm multiplying. Don't forget that. All right, so furthermore, using the distributive property, if I do 6 and I have 4x plus 3y in parentheses, I can solve this 2 ways. One, using the distributive property, and I'll take that back. Am I going to be able to use PEMDAS with this one? Because this 4x and this 3y, can I do anything with them? Their variables are very different. They're not the same variable. Can I combine them? No. So, the only way I'm going to be able to solve this is using the distributive property. So, I'm going to do 6 times 4x, and it's going to give me 24x. And then 6 times 3y is going to give me 18y. So, what we just did, we created an equivalent expression to this 4x plus 3y in parentheses with the 6 on the outside. Remember, that 6 beside that parentheses tells me that I am multiplying. You do not see a division sign. You don't see a plus sign. You don't see a division sign. You don't see a subtraction sign. You're multiplying, okay? Great. So the next thing that we're going to do, we're going to move on to solving, we're going to go on to solving expressions. So if I have 2x plus 5, and my x is going to equal, let's say, 15. So let's look at this. We know that when I have this 2 beside this x, it tells me that I am multiplying. Do not forget that I am multiplying, I am multiplying, I am multiplying, okay? In this case, they gave us the x. So all we're going to do is we're going to take this x value and substitute it into our problem for x. So I'm going to do 2. I'm going to keep it in parentheses, rewrite the rest of my problem here. Now I can solve this using PEMDAS, okay? So what am I going to do first? I have 2 times 15 plus 5. Do not do 15 plus 5 first and then think you're going to multiply your 2. It's not going to work. You're not going to get the right answer. So you need to do 2 times 15, which is going to give us what? It's going to give us 30, plus 5 is going to give us 35. Make sure you check your work. All right? So, now, what if we don't have the slightest idea, they don't give us the x value, and we want to figure out what x is. So let's say we're going to do 4x plus 3 equals 31. Okay? 4x plus 3 equals 31. Now, if you remember or recall that the goal here is to get x, what? By itself. In order to get x by itself, we always have to do the inverse operation. But before we can even do the inverse operation, we need to get this constant across the equal sign. And in order to make that happen, we have to do the what? Have to do the inverse operation. So if this plus sign is in front of this, what are we going to do to get it across the equal sign? That's always your question. You're going to subtract 3 from both sides. When I subtract 3 from here, from this side, if I have 3, positive 3, minus 3, it's going to give me a 0. And again, I am also subtracting from the other side of the equal sign. So that leaves me with 4x minus 28. Equals 28. Yep. All right. Now I have 4x equals 28. In order to undo this, again, remember that this 4 beside my variable tells me that I am multiplying. So in order to get on the other side of the equal sign, or in order to get this x by itself, I have to divide. The inverse operation of multiplication is division. So remember, whatever I do to one side, I have to do to the other. Okay? So I'm going to, if I have 4 divided by 4, it's going to give me 1. So it's going to give me 1x. And do I have to have that 1 in front of it? I don't. Absolutely not. And so then I have this 28 divided by 4, and we know that it's going to give us 7. So x equals 7. If we wanted to check ourselves, the only thing we have to do is take this x value, substitute it back into our original problem. So let's do that too. So I have 4. I'm going to substitute my 7 in, plus 3 equals 31. Okay? 4 times 7 is going to give me that 28. plus 3 equals 31. Checks out. We're good. All right. So the next thing that we're going to move on to are our inequalities. Okay? Inequalities. So inequality, that means I have greater than, less than, greater than or equal to, and less than or equal to signs. So let's recap on that for just a second. So I have greater than, I have less than, I have greater than or equal to, and then I have less than or equal to. Now, these are the signs that you're used to, that you've been working with for forever. Now, these two signs are something that are a little different, but this also means that whatever number's on the other side of it, that it's also equal to. So, if I were to have, x is less than 2. If I have x is less than 2, what x values can we put into this to make this inequality true? Remember, that is the question that you're asking yourself. You're asking yourself, which set of numbers can I put in here to make it true? Okay? So, ask yourselves, what? I'm pretty sure that x can equal 1, it can equal 0, and it can equal everything in my negative side of my number line, because we want to make sure that this 2 is the larger number, because remember, our mouth is open towards the larger number. Okay, now, same thing with solving inequalities. Whatever you do to one side, you have to do the other side, and you have to do the inverse operation. The goal, again, is to get the x by itself. So, if I have 2x is greater than or equal to 16. Very simple, very easy. I have 2x. How am I going to get the x by itself? This is multiplication. Don't forget, this 2 beside the variable is multiplication. To get it to the other side, I have to divide. I'm going to divide by 2 on both sides. Remember, whatever I do to one side, I have to do to the other side. So, this 2 divided by 2 is going to give me 1. And remember that if I just have a variable, it's an understood 1 to be in front of that variable. So, that marks out, I have just an x. I bring down my inequality. And then I solve. Remember that this division bar is also telling me to divide. So, if I have 16 divided by 2, which obviously is what? 8. So, the numbers that are going to satisfy this inequality are numbers that are going to be greater than or equal to 8. So, if I want to write my x values here are going to be, obviously, starting with 8, because it's equal to. It has to be greater than or equal to 8. So, I can do 8, I can do 9, I can do 10, I can do 11, I can do 12, etc., etc., etc. I can keep going on and on and on. Using that same inequality that we just used, we're going to plot that on our number line. So remember that if I have a regular greater than or equal to or greater than or less than sign, I have an open dot on my number line. Now the reason I have an open dot on my number line is because that number is not going to be included in that data set. Now, if I have a greater than or equal to or less than or equal to sign, I am going to have a closed dot, because that means that number is included because it has that equal sign. Okay, so think about it. Does not include it, does include it. So we've already solved it. So we know that x is greater than or equal to 8. So we're going to go to 8, and what kind of dot are we going to put? We're going to put a closed one. And then we've already figured out the numbers that can satisfy this inequality. So we know that 8, 9, 10, 11, 12, up until infinity can solve this, can satisfy this inequality. So we want to color in or shade in the numbers that will satisfy it. So it's going to be everything on this side. Now, if I were to draw my line back this way, I would be incorrect, because we know that 7, 6, 5, 4, 3, 2, 1 is not going to make this true. And that is it. If you will, go ahead and get this learning target down. It is 6EE9. I can determine the independent and dependent variable. It might be a good time to pause the video so that you can get these definitions down. So the first definition that you're going to need to get is an independent variable. So again, INDEPENDENT, independent variable, VARIABLE. An independent variable can be changed. That's it. Then your dependent variable. It's affected by the change in the independent variable. So again, for your dependent variable, you need to write that it's affected by the change in the independent variable. So what in the world does that even mean? So our first example, I'll just hop right into it with an example. We're gonna create a table. So we're gonna have an input. We're gonna have an output. And then we're gonna have rules for our table. So the rule for this table is gonna be x minus 4. Have an input, rule, output. So I have under input, I'm going to put 4, 7, and 10. As you can see, this looks familiar because we have a variable here. We have a variable, we have operation, and then we have a constant, okay? So we can name this input the same thing as x, or we can go even further. We can also name it our independent variable. And the only thing you're going to do, you're going to take these independent variables, you're going to plug it into the rule, and it's going to give you the output. Now, if my independent variable is called my input, and it's also my x, what in the world do you think this output is? Yep, you're right. It is your y and also your dependent variable. So, go ahead and complete the rules. So, for the first one, you're going to substitute this 4 into your rule. And you're going to do 4 minus 4. All I did was take this 4, plug it into my rule. I have 4 minus 4, and it's obviously going to give me that 0. If you will, go ahead and finish the table. All right, so I'm back with my completed table. I have my inputs, which are the same as my x, which is also called my independent variable. I have my rule, and I just substituted my input into my rule, and which gave me my output, which is also my y, which is also called my dependent variable. Now, the question we're going to ask ourselves is what kind of equation, now remember an equation has an equal sign, an expression does not. What kind of equation could I write to depict my graph? We're going to just use our rule. X minus 4 equals y. X minus 4 equals y. That's it, you guys. That is literally it. Now, the main thing that you need to keep in mind when you're doing independent and dependent variables is that your independent variable determines what your dependent variable is going to be. As you notice, our output changed, our dependent variable changed whenever we had an output. No, wait, I said that wrong. Our output changes whenever we put in a different input. The rules stay the same, but our dependent variable is dependent on our independent variable. Okay? So let's see if we can do this one. So again, you're going to have the same concept of you have your input, which is your x, or also your independent variable. You have your output, which is your y. And the rule for this particular table is going to be 3x plus 2. Now, the inputs that I'm going to have here are 5, 6, and 9. If you will, it might be a good time to pause the video and fill out the rest of the chart. So yes, I'm going to take these and I'm going to plug it in, and when I come back, I will have all of my y values for my dependent variables. Alright, so all I did was plug in my x value into my rule, and it gave me my y. Now, what is the equation for this particular independent-dependent situation? We're going to take our rule, set it equal to y. So our equation here is going to be 3x plus 2 equals y. That is it. Alright, so an example that I would like for you to do, we're going to kind of do it a little bit backwards. So I'm going to give you your independent and your dependent variables. So I'm going to give you your x, I'm going to give you your y. Now you have to try to determine what in the world am I doing to my x to get to my y. So my x values are going to be 24, 32, 48, and 60. My y values, or my dependent variables, are going to be 6, 8, 12, and 15. So again, don't forget that your independent variable determines what your dependent variable is. So you're asking yourself, what do I have to do to my x to get to my y? all the way down. What is the pattern? What am I doing to this number to get to this number? Now, if you look very closely, you'll realize that you're doing 24 divided by 4 is going to give us this 6. 32 divided by 4 is going to give us 8. 48 divided by 4 is going to give us 12. And the 60 divided by 15 is also divided by 4 is going to give us 15. So, what is the equation here? It's going to be x divided by 4 is going to give us this y. X divided by 4 equals y. Alright, so now some real life scenarios. Real life scenarios, okay? And I want you to see if you can determine which is my independent variable and which is my dependent variable. Remember that your dependent variable depends on what your independent variable is, okay? So, let's say this one is very relatable, okay? It says the more hours, which can be represented by H, that Bridget studies, the better her test grades will be, which is G. Alright, so it's just this bottom half. Again, ask yourself, which of these is my independent variable and which of these is my dependent variable? Your independent variable will determine your dependent variable. So if you look at this, it says the more hours that Bridget studies, the better her test grades will be. So if she studies more hours, will her test grade be better or will it be worse? If she doesn't study that much, so she studies less hours, is her grade going to be better or is it going to be worse? So it depends. This right here, the grade depends on how many hours she studies. So in this particular instance, our H, which is our hours, is going to be our independent variable. I'm going to put IV beside it. And our test grade is obviously going to be our dependent variable. That's it. Alright, so you might want to go back over that if you need to. After I finish recording this part, there will be practice questions on everything from the third 9 weeks. So please, please, please make sure you do those problems. Thank you.